In the previous video, we learned how to solve radical expressions or radical equations where we only had one radical expression on one side of the equation. In this video, we are going to be solving equations with radical expressions on both sides of the equations. So we're going to have square roots on both sides of the equations. So if we look at this first one, we have, what is the solution of the square root of 5x minus 11 is equal to the square root of x plus 5? Just like we did before in the previous video, to get rid of the square root sign, we're going to raise that to an exponent of 2. We're going to square both sides. And we're going to do that to both sides of the equations. And remember that when you raise a square root to an exponent of 2, the exponent of 2 undoes the square root sign. So we can cross that square root sign out, and what we have left is what is underneath that square root sign, which in this case is 5x minus 11. We can do the same thing on the right side, and we are left with just x plus 5. So then if we look at this now, all we have is an equation that we need to balance, that we need to solve for x. There are two x's here. We have x's on both sides, so we want to get the x's all on the same side. So we're going to subtract over this x to the other side. And remember, we're going to combine like terms. So we're going to take 5x minus x, which leaves us with 4x minus 11 equals just 5, because the x's ended up canceling each other out. And then we need to get all the numbers on the same side. So we need to move this 11 over to the other side. To get rid of a negative 11, we're going to add 11 to both sides. That leaves us with 4x on the left and 16 on the right. To get rid of the 4 out front of x, because we're really taking 4 times x, to get rid of that 4, we're going to divide by 4 on both sides. The 4's cancel out. You are left with x is equal to 4. And just like before, we are going to check our answers. We can check our answers by replacing the x value with 4. So we have the square root of 5 times 4 minus 11 is equal to 4 plus 5. And remember, all I'm doing is replacing x with 4 with the answer we got. So that gives us 5 times 4, which is 20, minus 11 underneath the square root, and 4 plus 5, which is 9. We have to simplify the left side further. We're going to take 20 minus 11, which is 9. So square root of 9 is equal to the square root of 9. We now know that our check worked, that x equals 4 does satisfy this equation. You could simplify it further, though, and say that the square root of 9, which is 3, is equal to 3. But we do know that x equals 4 is a solution. Now we're going to do that again with this equation, where we have the square root of 7x minus 4 and square root of 5x plus 10. We're going to square both sides to get rid of that square root sign. So on the left here, we have 7x minus 4 is equal to 5x plus 10. Again, we're just balancing an equation. We're trying to solve for x. So we need to get all the x's on the same side. To do that, we are going to subtract the 5x. That leaves us with 7x minus 5x, which is 2x minus 4 is equal to 10 on the right side. And then we have to get rid of that -4. We want to move it over with 10. So we're going to add 4 to both sides. And we are left with 2x on the left and 14 on the right. To get x completely by itself, we're going to divide by 2. That gives us x equals 7 as an answer. We want to check our answer, make sure that it works. So we're going to check our answer, and we do that by replacing x in the original equation. We're going to have 7 times 7 minus 4 is equal to the square root of 5 times 7 plus 10. And then simplify what's underneath the square root sign. We have 7 times 7, which is 49 minus 4. That gives us 45 is equal to the square root of 5 times 7, which is 35, plus 10. That gives us 45. And we now know that our answer does work. It satisfies the equation. So x equals 7 is our answer here. Now that you've seen those two examples, you can practice some of those types of problems on your own.